Hi guys, welcome back to my physics class. I hope you are doing well. So our quarterly exam is around the corner. In case you have started your preparation, then this is the right place. So let's make this revision very simple and very efficient. Okay, so let's begin now. So we have taken here the MCQ. Okay, so the first included portions. Okay, let me tell you the brief you the included portions. So we have units and measurements. Motion in a straight line, motion in a plane, laws of motion, and work and energy only till conservation of mechanical energy. Okay, so these are the included portions for Bangalore North students. Now moving to the MCQs, I've taken a few MCQs, okay, and fill in the blanks. First, let us cover these. Okay, so you can take it as a model paper. So the first question, the number of significant figures in 53.00 into 10 power 3. So what's the total number of significant figures here? Okay, yes. So 5, 3, since decimal is there, so even this will be included. Okay, even that is significant. So that's the reason the total number of significant figure will be 4 students. So if in case if there is a 10 power 3 or 10 power 4, that's not significant. Okay, so if you have something like 5, 3, and since decimal is there, then that's significant. But in case if the question, so the option is option A, 4. In case if the question was 5300, since there is no decimal, therefore only the significant figure will be 2 students. So please remember this, and significant figures question, it's compulsory. Okay, for 1 mark it will be asked. Next, an object is moving with uniform velocity, then its acceleration, of course, if it is uniform velocity, there is no change in the velocity, therefore the acceleration is 0. Next, the stopping distance. Okay, you should be remembering the stopping distance formula. So, okay, directly I'll just mention the stopping distance is directly proportional to the square of velocity. Okay, so option 4. Yes, so it is directly proportional to square of initial velocity of vehicle. Please remember this point. Okay, so moving to the next, scalar product of two vectors is always in case if I take two vectors, if it is a scalar product, then the product of both the vector will always be scalar, students. Please remember this. Okay, in case if it is a product of scalar and vector, then the resultant will be vector. Okay, in case if it is a product of vector and vector, then the resultant can be either scalar or vector. Please remember this. Okay, next, moving to the, okay, in the projectile motion at the highest point. So you all know the high projectile motion, right? So at the highest point, you would have discussed the velocity will be 0. So where do we have that as velocity? Yes, we have here velocity. Okay, there is a two velocity, horizontal velocity and vertical velocity. So what might be the 0 over here? Or both horizontal velocity is 0 and neither vertical or horizontal component. So what do you think? What might be the correct option? So at the highest point, the horizontal component of velocity will be 0, students. Okay, so option B is the correct answer. Next, action and reaction. As you all know in Newton's third law, for every action there's equal and opposite reaction, right? So action and reaction always act on, okay, so fine. This mistake, I think even you might do this. See, there are two options here, equal and opposite. Yes, it's correct. And also it is act on two different bodies as mentioned. Therefore, can we say both option A and B is correct? Okay, so remember, action and reaction will always act on two different bodies. Next, the area under force displacement. Okay, for this, please remember the slope of the graph and area under the graph. Okay, I'll give you one hint to remember. In case if it is a slope of distance time or slope of velocity time, then you will divide those two quantities. Okay, in case if it is area, then you will multiply those two quantities. Okay, so please remember this. So now it is area. Area means you will multiply the two quantities which is given here. Now force into displacement. If you multiply, what do you get? Force into displacement gives work. Therefore option A is the correct answer. Please remember this. Okay, so moving to the next, which of the following is unit of length? Per second, light year, astronomical unit, all of these. So as you all know, light year means what? In a year, how much the distance the light travels. Okay, again, it comes under the quantity of distance, even the parsecond is distance, therefore all of these will be the correct option. Next, okay, so now I think you can give this a try. Area under acceleration time graph. So as I mentioned, if it is slope, then you will multiply. If it is area, slope, you will divide. And if it is area, you will multiply the two quantities. So here the acceleration time and area is mentioned. So what we have to do? We have to multiply, right? So acceleration multiplied by time gives what, students? Of course, it is velocity, because we know that acceleration is velocity divided by time. So acceleration into time gives velocity. So velocity will be the perfect option. Next, which of the following statement is wrong? Please look at the option. Distance is path dependent, displacement may be zero, positive or negative, speed is always positive, and acceleration is scalar. So very perfectly we can say that acceleration is scalar, which is a wrong option. Why? Because acceleration is vector quantity. Next, which of the following is not a vector quantity? Force, displacement, moment of force, distance. Of course, the answer is distance, because distance is a scalar quantity, right? It is not a which of the following is not a vector quantity? That means which of the following is a scalar quantity? Of course, the distance will be the correct answer. Okay, so moving to the next. Resultant of two vectors are maximum when? Okay, so please remember this. We have like two vectors moving in the direction, opposite direction, and perpendicular. Okay, so you have a derivation also in that. When we are deriving, I will mention about that. So remember, when it is maximum, when they both are acting in the same direction. When the angle between the two vectors is 0 degree, students. That time what happens? The resultant of two vectors will be maximum. Remember this. Now moving to the next question. Four forces each of magnitude 10 Newton, okay, act on four bodies A, B, C, D where masses are given. Where in which case acceleration is maximum. Okay, so we know this formula, right? F equals ma, where acceleration is inversely proportional to mass. Therefore, in which case acceleration is maximum? For which mass is less. So out of A, B, C, D, in which case the mass is less, students? Of course, it is A, 10 kg, right? So option A will be the correct answer. Okay, next, which of the following has both potential and kinetic energy? Where potential energy is something a stored energy, kinetic energy is something a moving. Okay, so if it is in motion, then we say that energy has kinetic energy. Of course, the answer is waterfall. So waterfall has both potential as well as kinetic energy. Okay, fine. Moving to the next. Fill in the blanks. Okay, we have taken, so you will have 7 MCQs and 3 fill in the blanks. So I'll be dealing with like 3 model papers I'll be discussing now. Okay, if you have any doubts, please drop your message in the comment box. Okay, now moving to the fill in the blanks. So physical quantity having the same units in all the system. Which is that quantity which has same in all the system of units? Of course, it is time, right? Because we have CGS system, FPS system, MK system. So in all the cases, the time or a second is same. Therefore, option time, so time is the perfect answer. Next, friction is due to the intermolecular forces of course, it is a attraction. Okay, forces of attraction. Next, if the work done by a force is on a body is 0, then what will be the kinetic energy? Of course, it's not 0. Then which is the correct option here? I've already taken attraction. Time is done. Therefore, we have remain same, repulsion. Of course, it should not be a repulsion. Therefore, the correct option is remains the C. Okay, so this completes the fill in the blanks and for one first model paper. Now, moving to the second one. So the difference between a measured value and a true value, of course, you would have done this in your practical also. Whenever you have a measured value and true value, if you take a difference, of course, the answer will be error. Next, a ball is thrown vertically upwards at a maximum height. Okay, when I'm throwing at the maximum height, as we know, the velocity is 0. Okay, at that point, even a gravity will be acting where gravity is always downwards. So, which is the correct option here? So option, yes, the instantaneous velocity is 0 and acceleration is downward. So that's a perfect option. Next, moving to the next question. See, again, this question has appeared here. The slope of velocity time graph. As I mentioned, if it is slope, what you have to do? Slope is nothing but division, right? So you will divide velocity by time. So what does velocity by time gives? Nothing but acceleration. Therefore, option B is the correct answer. Okay, moving to the next. If A cross B is 0, then what is the angle between them? Okay, since the magnitude is given, fine, it is 0 degree. It can be 180 also actually. I think both the options are correct. Okay, so angle between them will be either 0 degree or 180 degree. As I mentioned, if it is in the same direction, then the maximum resultant force. Okay, if it is in the opposite direction, of course it is minimum, but since here magnitude is given, that's the reason I'm taking both the options over here. Fine. What's the minimum number of force needed to be keep a body in equilibrium? Okay, equilibrium is something where a body is at rest. If you are applying 2 or more forces in different direction, and if that object is at rest, then we say that object is said to be in equilibrium. So please remember the minimum number of force to keep a body in equilibrium is 3. Okay, so option D is the correct answer. Next, the ratio of maximum limiting frictional force to normal reaction. So for that, let us remember the frictional force formula. So the frictional force formula is always directly proportional to the normal, right? Okay, is always directly proportional to the normal reaction force. Okay, so this proportionality will be replaced by a constant called mu. Mu is nothing but what? Coefficient of friction. So they're asking you here, what is the ratio of frictional force to normal reaction? Therefore, frictional force to normal reaction gives what, students? Of course, it is coefficient of friction. So option B is the correct answer. Okay, next, the work done by centripetal force. Okay, centripetal force is something which appears when an object is moving in a circular path, right? It keeps an object to be in a circular path. And please remember, if it is a work done for a circular path, of course that object comes back to its initial position. That's the reason in any case, a work done will always be a 0 for a circular path. So that's the reason the work done by centripetal force is 0. Okay. Now, next, fill in the blanks. Yes, it is very easy question. Dash is a process of comparison of two physical quantities. Okay. So, of course, a measurement is a process of. Okay, I'll just mention as one over here. So this is the first question, second question, and third. So measurement is a process of comparison of given physical quantity with unknown. Okay, now in case if I have to measure the length of this pen, then I'll be using the scale, which is a known quantity, right? And this pencil is an unknown quantity. If I'm comparing known with unknown, then that's what we call it as measurement. Fine. Next, dash of a projectile is parabola. So of course the answer is trajectory of a projectile is parabola. Inertia measures what of body? So inertia is always directly proportional to mass. More the mass, more the inertia. So therefore the option is mass. Okay, so this completes the second model paper. Please watch it throughout, okay, till the end. In case if you want, you can increase the speed of the video, but please watch till the end. I hope it will help you for your quarterly exam. Okay, it's fine. Moving to the next. Yeah. Okay, I've taken two model papers. Okay, now let's start our 5 markers. Okay, so most important 5 markers you will be getting. And you'll have options. Since this is your first time you're writing your quarterly exam, so that's the reason I've taken like all the most expected questions over here. So if you're studying all these, confirm you will be getting either one question, it's confirmed you will be getting in your exam. Okay, fine. Now I'll try to reduce this complexity. Okay, because of course derivations you might find it quite difficult. So that's the reason I'll be deriving it in a quite simpler way. Okay, so this is our most expected derivation. I'll teach you the hint to derive this. Okay, so first here they have asked like by the method of dimension, obtain the expression for time period of a simple pendulum, and it depends on mass. So that's the reason time period. Okay, time period I'll denote it as capital T, mass I will denote it as m, length L, and acceleration due to gravity is g. For that, you should be knowing the dimensional formula for all these quantity students. Okay. So now they are saying that time is directly proportional to mass, length, gravity. So first step, you will do this. And the time is depending on that. Since proportionality, you can be replacing it with constant K, M, L, G. Okay. Now, what you can do is, you can just put the powers for this. M power A, L power B, G power C. You can just put either anything. It need not be in the same order. You can keep G, L, M, anything you can keep. But put the powers as A, B, C. Next, this is a first step. Okay, so the next step, this is you are deriving by the method of dimensions. So take a dimensional formula for this. Time period dimensional formula. So the time period dimensional formula, I will be starting from here. The time period dimensional formula, I will be writing it as M0, L0, T power 1. Okay, time is something 1. Okay, power. Next, because there's no mass and length, so T power 1. K, you can just write as it is. Mass dimensional formula, directly write it as M to the power of A. Length dimensional formula, L to the power of B. G is nothing but what? Acceleration. Please remember the acceleration dimensional formula, which is L1 T minus 2 to the power of C. Okay, now moving to this, just take the powers M power A, L power B. Again, L power 1 power C is C and T power minus Okay, so to equate LHS and RHS, so what we can do is we'll just take one particular MLT. Okay, so M par. Okay, whenever you are writing dimensional formula, this is very important, the brackets. So now M par A, there's only one M. Since we have L par B, L par C, so what we'll do is we'll multiply those two. So how to multiply the powers? L par B into L par C will be L par B plus C, and then T par minus 2C. Directly you can write this. So now it's time to compare now. Okay, M par 0, L par 0, T par 1. Now try to compare only M with M. So when I compare M and M from LHS and RHS, you observe that the power A will be equal to 0 students. So finally we found A. So what we are doing here in this, we are finding A, B, C. Now I found A. Next, now I'll compare L with L. So what do you get? The powers B plus C will be equal to what? 0. So if B plus C equals 0, then I can take B equals minus C. But still I have not found the value of B and C. So let's move to the next term. Now I'll compare T with T students. So compare T power 1, T power minus 2C. So you will get minus 2C as 1. Therefore C will be equal to minus 1 by 2. If C is minus 1 by 2, then B will be minus of minus 1 by 2, which is equal to 1 by 2. Finally, I found A, B, C. So what you can do is you can substitute to the main equation. So what was our main equation over here? Main equation was T equals K, M par in place of A put 0, L par in place of B put half, and G par minus half. In place of C put minus half. Okay, so now you can see here time or whatever, K is constant, M par 0 is 1, therefore directly proportional to L par half and G par minus half. Can we write it as root of L divided by G? Yes, because L by half is nothing but root of, right? So root of L by G. Therefore, this will be the final expression. So we are deriving an expression for time period in terms of mass, length and gravity using the method of dimension. Okay, so this is what you have to do. So please follow this two or three steps method. First, you will take what factor it depends on. Then you will take its dimension, and the third thing is you will equate them, and finally found what is ABC, substitute in place of that. Okay, so finally you will get this. And one thing you can just make a note here, time is independent of mass. Okay, you can see in final expression there is nowhere mass. So remember this, time is independent of mass. Time period is independent of mass of the ball. Okay, I hope you understood this derivation. The same methodology you can apply for the next derivations also. Okay, so we have around 3 derivations. Okay, like time period depending on this. And the next derivation will be derive an expression for centripetal force. So here centripetal force depends on mass of the particle, velocity, radius. Okay, so as I told, it's the same method you can use. So first you will put M par A, B par B, R par C. Okay, and then take its dimensional formula. Please remember all the basics dimensional formula here. So the force dimensional formula will be M1, L1, T minus 2, directly proportional to M par A means M par A, velocity means L par 1, T par minus 1 to the power of B, and radius, of course, it's a category of length, so directly take L par C. Then finally compare, and final expression you should be getting as F equals mv square by R. So I want you to try this using the same methodology. Okay. So use the same methodology what I explained. Using the same methodology, try to apply that here and derive this expression. Okay, I hope you will do this. And then next derivation, similar ones will be derive an expression for centripetal acceleration. So force was mv square by r, right? So force expression is mv square by r. Also, we know that F equals m into a. That's the reason the acceleration expression will be a equals v square by r. Okay, so this should be a final expression. I want you people to try this and let me know whether you tried it or not using the same methodology what I taught you. Okay, fine. So now we'll move to the next set of derivation. Okay, so here it is a velocity time graph. Yes, this is one of the most expected question. So you would have learned all the 3 equation of motion, right? V equals u plus at, v square minus u square equals 2as, and s equals ut plus half at square. Okay, so the same, all the 3 equations, we will be deriving it here, and they're asking what is velocity time graph. Okay, so anything they can ask, but I will teach you all together, all the 3 derivations I'll be teaching together. But in a paper, they might ask you any of it. Okay, so we can't say anything. And then you should be knowing what is velocity time graph. So please remember, it's a graph of what? Velocity versus time, where velocity on y-axis and time on x-axis. You can just mention this much for 1 mark. Okay, so now let's derive this expression. So for deriving, firstly what we have to do is, let's take a axis. Okay, and then this is, I'll take origin. So this is x-axis and y-axis. Okay, so on x-axis we have time. So for that, let me take okay, an object will start its motion from this point and it will have a uniform motion. So we are taking uniformly accelerated motion over here. Okay, so for that, yeah, it's a straight line. Then you can draw one perpendicular line. I'll just draw one perpendicular line over here. Okay, join this. So I'll name this now A, B, C, D, and yeah, I'll join even this E. As this is velocity time graph, I'll just take it now. So OE will be, students, okay, OE will be taken as V and OA will be taken as U, where U stands for initial velocity. And then OD will be taken as time. Okay. If OA is U, can we say even CD is U? Because it's parallel, right? So I'll just mention it over here itself. CD is also U. If OE is V, can we say BD is also V? So even BD will also be equal to V. If OD is time, can we say AC or BE is also time? Because they all are parallel sides. One minute, AC and then BE. This is equal to OD, this is equal to time. So firstly, we'll label like this. Okay, what are those quantities? We'll just make a note of it. Okay, now, so firstly, we need to prove three equation of motion. I'll just mention that three equation of motion over here. So, okay, fine. The first equation of motion we will be proving is V equals U plus AT. They can ask you as V equals U plus AT. If not, they can ask you as V equals, in place of U, they might write V naught plus A into T. Okay, in place of U, they might write V naught. So remember this. So moving to the first derivation. So first derivation is like we need to prove V equals U plus AT. It's a very simple derivation. What you have to do is you have to just take a slope of this graph. Okay, so let me take a slope of the graph. So slope of velocity time graph, slope of velocity time graph gives, what is slope of velocity time graph gives? Of course, V divided by T will give you acceleration. So acceleration equals, so take a slope of the graph. So you all know how to take a slope, right? So if this is a slope, then you will take y-axis divided by x-axis. So y-axis is BC divided by x-axis is AC. So what do we have BC here? If OE is V and OA is U, can we say this BC as V minus U? Because this complete thing is V and this is U. Therefore, this remaining part will be V minus U. So BC is given as V minus U and AC is what? AC is time. Therefore, we have A equals V minus U by T. If you cross multiply, you get V minus U equals AT, or we can write V equals U plus AT. That's it. So this is your first derivation. Very simple derivation. Okay, just take a slope of the graph. That's it. And then label them. What is it? And remember how to take a slope, because many students even they doesn't even know how to take a slope. So slope is always taken as y-axis by x-axis. Remember this. Fine. Now moving to the second part. Second part of the derivation, that is second equation. We'll have to prove S equals ut plus half AT square. And if they ask you S equals V naught T plus half AT square, don't worry, the same derivation it is. In place of U, they are just denoting it as V naught. Okay, fine. So for the second graph, what we'll do here is we will take an area under the graph. Okay, so area under the graph. Okay, area under the velocity time graph. So what does area under the velocity time graph gives? So area means you will multiply velocity into time. What does velocity into time gives? Of course, it is displacement. So I will relate it as S as displacement. Okay. Now let me take an area under the graph. So this is the area under the graph. So can you see here? We have one triangle. We have a rectangle, right? So area of the graph, I'll take it as area of triangle plus area of rectangle. Okay, so area of triangle, take a area of triangle, we know that half into base into height. Whereas area of rectangle is length into breadth. Now, half, look at the area of triangle, this is a triangle, therefore base is AC. Okay, next, height will be BC. So this will be for a triangle. Next, for a rectangle, length, I'll take it as OD and breadth, I'll take it as OA. Okay, so S is equals to. Now just substitute what is AC and all. So what is AC? Can you all see here? AC is what? Time. Then BC. What is BC? V minus U. We already found this. Plus, what is OD? Look at this OD. OD is again time. And OA is what? U. Okay, we are almost very close to our derivation, right? So we got S is equals to, we got U into T directly right here, UT plus half T. But V minus U we have. What is V minus U? We have already found V minus U is what? AT. Since we can write here, since V minus U equals AT, so directly you can substitute over here as ut plus what? V minus u as a into t. Finally, we are getting s equals ut plus half a t square. That's it. Okay, so this is the second derivation, that is s equals ut plus half a t square. Okay, I hope you understood this. Now, moving to the third derivation. Again, this is one of the easiest derivation. I'll just erase this so that I'll finish it off over here itself. Now, moving to the third derivation. Again, for the third derivation, we need area under the graph. Okay. So, area under velocity time graph. Okay. Area under the velocity time graph. So, as we know, area under the velocity time graph gives displacement. Okay, so I am writing displacement. See, we have already found the area as triangle plus rectangle, right? So, what do we have next? We have already found, again we might get the same derivation. So, what we will do here is, look at the shape carefully, the area under the curve. So, this will represent what, guys? Of course, it is trapezium. How can we say it's trapezium? Because we have two parallel sides and one height which is connecting those two parallel sides. Okay, so you can see here OA and BD is a parallel side. OD will be what? The height which is connecting those two parallel sides. So now what we will do is we will take our area under the graph as area of trapezium. So please remember the area of trapezium. So area of trapezium is what? Half of sum of sides into height which is connecting those two sides. So now S equals half. What are the two sides here? Can you see these two sides? So two side will be OA plus BD. So A will be taken as OA and the other one is what? BD. So what is that height which is connecting those two parallel sides? Of course it is OD. So just mention it as OD. Now substitute finally. So OA is what? OA is U plus BD is V. And OD is what? Time here. Okay, so we got only S equals half of U plus V into T. But we need to get what? V square minus U square equals 2AS, right? So, but of course, there's some substitution or something else had to be done, right? So, for that, what we will do is, again, we'll make use of the first derivation. Okay, so V minus U equals 80, we took it over here. So, now what we will do is, we will take time here as, we will take from the first equation, we will take time as, what should I take time as? T equals V minus U by A. Okay, so S equals half of U plus V into V minus U by A. So U plus V plus U into V minus U, V minus U gives V square minus U square divided by 2A. So S equals V square minus U square by 2A. Finally, we are getting V square minus U square equals 2AS. Hence, proved. Okay, so these are the most expected derivation. I'm just covering from first two chapters for now because we are almost very close to our quarterly exam. Okay, Yeah, so these are the most expected 5 mark questions. In case if you need any like most expected questions or something, we will try to post it in our group. So please follow. Yeah, thank you so much. Thank you for watching.